Fantastic. So I'm going to scroll down, and this is kind of a list of all of the mini workshops we've held during the quarantine. And I'm going to go down to this Tidyverse tables and bits, a name that I did not make, but is great. It's fine. To introduce the Tidyverse package in R. So I'm going to click this Launch Binder button that hopefully everyone sees. And if you're having any difficulties at this stage, please just let us know in the chat. And hopefully this should not take too long. And while this loads, I would just like to note that I'll try to maximize the number of people on the same page and introduce all of the basic concepts for people who might not be super familiar with R. But again, if you have any questions, let me know. And if we move too slow for you, you can just look at the material yourself and go at a faster pace if you wish. Okay, so this loaded for me. Let me adjust some things here. Okay, so I'm gonna increase the font size a little bit. And I'm also going to click this little window pane here to open up this other window here. So this is our studio. For those who aren't familiar, we have a text document. We have the R console. This is our file system over here in the lower right. I'm going to click on this Tidyverse directory. And in it is this R markdown file. It's just R code that's written in a special markdown format. I'm going to click this, and that is going to open up a text file over here. Let me make this a little bigger. Okay, so this is where our documented R code will be. And again, it's in R markdown format. When you write your own R code, it doesn't need to be in this format. We just put it in this format for the workshop. So for instance, you don't need any of this stuff in your own code. The only kind of code you'll need is, let me just jump ahead. You might write out your code that looks something like this, but all of these other little bells and whistles here, you do not necessarily need. Okay, so today we'll be talking about the Tidyverse, and backing up a little bit, one of the reasons that R is so useful is because it's been used by so many people, and lots of people have made packages for R, which is basically a collection of code that you can download and install and run on your own data sets. So you don't have to kind of make all of your own code from scratch. And these packages can do very broad statistical analyses, relevant to almost any data set, or they can be very focused analyses, for instance, looking at phylogenetic trees and doing specific tests. So this brief lesson, which will be in two parts, will introduce some data manipulation tools from Tidyverse. And by data manipulation, we mean, if you get a data table, there's a good chance that either you'll want to analyze it, or even before you analyze it, you'll need to change it in certain ways. You change column names, you change the way columns and rows are represented, etc. And Tidyverse gives you the ability to do many of these tasks that you would want to do. So Tidyverse is actually a collection of packages. I think it's like maybe 5 or so. And the two packages that we will talk about are tidyr, and which is shown here, and dplyr. So tidyr I'll just mention because it's really important, but we won't cover that today. And it helps you convert your data from long format to wide format. In the next session, maybe we'll discuss more what these terms are, but we'll gloss over them today and mostly talk about dplyr, which we'll use to take our data table and filter say we only want to look at columns that have certain values, rows that have certain labels, etc. For a general overview of Tidyverse, I welcome you to look at this cheat sheet, which, I'm just going to copy and paste this here. If you, use this knit function, you can make this R markdown turn into a PDF or HTML, in which case this would be hyperlinked and we could just click it. But I'm just going to copy and paste this here and show you what this cheat sheet looks like that I'm referring to. So, Tidyverse has several packages and many commands. Please don't feel stressed out that you need to memorize all these commands. You can always just keep one of these cheat sheets up, either bookmark it or you can print it out and put it on your wall. And the reason I like this cheat sheet is that it not only lists all of the commands that we might want to use, but also kind of shows graphically what some of them might do. So very briefly, I talked about long format versus wide format, which you can see is shown here, is a way of kind of transforming your data table using these tidyr functions. But today we'll mostly be talking about these dplyr functions. So as you can see, for subsetting observations, dplyr : filter. And this : just means, in the dplyr package, there's a filter function. This double colon symbol is actually seen many places. So you'll likely encounter it again. Okay, so that's the cheat sheet. I highly recommend you reference that as you work with Tidyverse, because even I routinely forget commands. If we have never used Tidyverse before or installed it, you first need to install it using this install packages function. Because we've already installed it in this little binder we've created for you, I'm not going to do this, but just for completion, I wanted to show how you would install a package, and you only need to do this once on your computer. So once this package is already installed, you can't use it yet. You have to load it, and you load it using this library function right here. And in general, when you're writing R code, it's good to have these library functions at the top of your code such that you load all the libraries you'll need, and then you start writing your analyses below that. And if you quit R and then restart it, you'll need to execute these library functions again to reload the libraries. But you do not need to install the package again. So to load the library, we can just press this little play button over here. And the reason we can do this is because this code was written in R Markdown. But you don't need to do it. You can also, just copy and paste this code into the console down here. So if you were just running R from the console, we can just type it down here as well. Okay, so as you can see, these are the packages that were loaded when we loaded Tidyverse. It also shows it up here too, in this R Markdown file, or in this window pane up here. Okay, so let's load some data that we're going to use. This data involves the housing indices across the United States for a variety of years, I believe up until like 2015 or something. And to load this data, again, we can just press this play button over here. And as you can see, because we're using RStudio, in this environment pane, I can see that a new data set called housing has been loaded. Okay, so a brief introduction to Tibbles. So when you install R, just base R, which means no additional packages, the primary data structure that people use to store their data is called a data frame. It has columns, it has rows. Some of the columns might be named. But in the Tidyverse, it uses a slightly modified version of this data frame that's called a tibble. And it's very similar, but it has some additional properties that are quite nice. So in this code here, we're going to make a data frame. It's going to be very simple. It's going to have 4 columns that are labeled rep 1, rep 2, rep 3, rep 4, and it's going to have some data. And then we're going to take this data frame. So let me just run this code. As you can see, actually, sorry, I misspoke. This data frame has rows that are labeled rep 1, rep 2, rep 3, rep 4. And then the data for replicate 1 is in the data column. But one instance of data manipulation that we might need to do is, for instance, take this table and transform it such that columns are labeled rep 1 to rep 4, and that the first row is these data. So functions in Tidyverse kind of allow you to do manipulations like that quite easily. Okay, so we took this data frame called df1, and we made a new object that is called tibble, tb df1. And basically all we did was we took this data frame and put it into this function as .tibble. And now we have a new data frame, a new tibble called tbdf1. And I'm actually, sorry, that introduced a lot of white space. Let me X this out. And one of the nice things about tibbles is if you type the name of the tibble and press enter, it displays, it can't be seen with this example because our data frame is so tiny. But if you type the name of the tibble and press enter, you only see the first 10 rows, which is really nice because perhaps you forgot exactly what column names were, or you want to get a general idea of what your data table looks like. You can always just type the name and press enter. If you did this with a data frame, it would display the contents of the entire data frame to the screen, which can be a problem if your data table has tens of thousands of entries. Okay. And again, I'm kind of just paraphrasing this text here, and I'm going to include this text so you guys can go back and walk through this workshop step by step on your own if you like. But if you need to convert your tibble back into a data frame, say you're using some package that was developed, not under the Tidyverse, but under base R, you can simply take your tibble and put it into this as.data.frame function, just putting the name of your tibble in between these parentheses. Okay, so here's a block of code that I'm going to gloss over, and maybe I'll cover the details next time. But I wanted to cover some functions in dplyr that kind of require a slightly more polished data set. And this block of code polishes our housing data set and stores all of that into a new data set called housing_clean. So I'm just going to press play over here. And again, as you can see, I now have a new data set called housing.clean. Oh, sorry, over here. And so I'm not going to go over the details of what exactly is happening here, but I would like to cover one thing, which is these weird symbols called parentheses, or it's parentheses greater than parentheses. And these act as Unix pipes. So if you have ever coded in Unix, sometimes you type a vertical line, and it basically means take the output of whatever is on the left and give it to whatever is on the right. So here what's happening is we're taking our housing data set, we're piping it into this as tibble function, and then once we have housing as a tibble, we're going to pipe that into the gather function. And then whatever happens after this gather function is going to be piped into this separate function, etc. The reason it's really nice and that we highly recommend you code like this is it's much easier to debug and it looks a lot cleaner. For instance, if we did not use these pipes, we would have these long nested functions where, for instance, gather would be fed, as Tibble parentheses housing. So we'd have tons of parentheses all on one line, and it would be much more difficult to debug because let's say we ran this code and an error happened. What I would do next is I would say, okay, where's the error? Let's run just this first line. If you ran it, no errors, great, it's not there. Housing, we converted our housing data structure into a Tibble successfully. And then I would highlight the first 2 lines and run this code. Let's say there are no errors, fantastic. If I ran the 3rd line and suddenly I saw the error, then I know that somewhere in this separate function, I perhaps typed something incorrectly. If we did everything in one line, not using these pipes, it would be very difficult to see exactly, or it would take much longer to see exactly where your typo is. Okay, so we have a cleaned housing data set, and let me just briefly look at what this looks like, just to familiarize ourselves. So it has some columns with names, date, year, month. This is the national housing index for this particular date. And then the housing index can also be for each state, and within states, each cities. And the local index is the local housing index for this city, and some cities have missing data. So this, even though we're not interested, we may not be interested in the housing index, this data table kind of has many of the features that we would see in data sets we would be interested in. For instance, something biological. Okay, cool. Let's get started. So let's subset and manipulate this data set using this dplyr package. So like with the other packages in Tidyverse, dplyr has a bunch of functions that are just verbs, and these verbs do what you would think they do. For instance, the filter function will filter your data, only selecting certain rows that satisfy a particular condition. And some functions we'll go over today are arrange, rename, select, mutate, and these functions kind of do exactly like you might expect them to do. Well, mutate changes a column name. It's maybe not exactly clear what mutate does, because at least for me, I think of DNA mutating, not data tables mutating, but ultimately it's changing something. Okay, and again, if you forget any of these functions, just have one of these cheat sheets that I recommended above, just kind of displayed to your screen. So arrange sorts by one or more columns. And it uses additional columns to break ties. So for instance, if we see A for 2 particular cells, such that we could arrange them top or bottom, it doesn't matter. It uses another column to sort. But it's best to learn by an example. So let's just look at what these functions do. So here we're taking housing clean and we're piping it into arrange. And we want to arrange the housing clean data set first by year and then by month. So I'm going to press play here. And as you can see, so what happened is because all of these commands were executed in this one code block, it produced 4 additional Tibbles. So the output of this arrange command is actually another Tibble. It took our Tibble, it arranged it, and then it output another one. So to look at this first one, I can click this box here. And as you can see, I'm just going to scroll down a little bit here. It arranged by year and then by month. And as you can see, 1987 is the earliest year in this data set. And if we were to scroll all the way down to the bottom, it would go to the latest year. And after it sorts by year, it then sorts by month, which correspond to 1 through 12, the 12 months of the year. Likewise, I'm gonna just click the second one here, which corresponds to this piece of code here, where we arranged by city and then by year. And as you can see, the city that's listed on top is Atlanta, whereas, if we were to scroll down, we might see New Orleans, etc. And then it sorts by year, 1987. Okay, so I'm not going to go through those other two examples, but you can hopefully see the trend. So that's the arrange function. But let's say we want to rename a column. Here we can use the rename function. So here we're going to take housing clean. We're going to pipe it into this arrange function, and then pipe it into this rename function, which is going to take the column that was previously named national.us, and it's going to rename it national_index, which perhaps is a little more informative because it has index in the name. And as you can see, we're taking our data frame. This is the first operation we're going to do, and then whatever happens from that operation will give the output to the next operation, rename. So we're doing two different things to the housing clean data set. So I'll press play over here. And as again, you can see now this column is named differently. And we've also sorted it by year, by month, by state, and by city. Select is another important function where we can select columns to keep. So for instance, let's say there are some columns in the original data matrix that we no longer want. We can, for instance, remove those. So here we're taking housing clean. Again, we're piping it into the same arrange statement up here, but instead of using this rename, we'll use this select function. So here, we're going to only select the columns labeled year, month, city, state, local index, and as you can see, we're going to select the national US column, but simultaneously rename it national_index. So here above, we use this rename function to rename that column. And here we're doing the exact same thing, except within this select function. So again, there's a little bit of flexibility in how exactly you code some of these operations. So I'll press play. Again, you can see we've only selected certain columns, and the national index, the national.us column has been relabeled. Another super useful function is this distinct. It's like unique, which is another function in R, and it can be used to identify all unique values in your data table. So here, let's say we wanted to know in this housing clean data set, which had tens, or actually I forgot, it had thousands of rows. But let's say we want to know what cities and states are represented in this data set. But for each state, there are tons of rows because there's data for each month for many years. To get an idea of how many states and cities there are in this data set, we can take housing clean, pipe it into this select function. So we're only going to select the columns named state and city, and then we're going to feed the output of that into this distinct function. So I'm going to press play, and as you can see, for surprisingly little code, we can now see which states and cities are represented in our dataset. Super useful. I use this all the time. This mutate function, it creates new columns, or it may also update existing ones while keeping everything else in your data table unchanged. So to use the mutate column, again, these two lines of code were taken from above, where we just take our data table, we arrange it, and then select certain columns. And then we use this mutate column to change the month column. We change it in a way that basically takes the months, which are in terms of integers, 1 through 12, and it changes them so that they're January, February, March, April, etc., using this month.abb vector, which is in R. So many times you might not need to do this, if your data are not in terms of months, but this is a useful function in case you do. So now you can see month corresponds to January, February, March, etc., instead of 1, 2, 3, 4. So again, mutate changes this column. We can also do several mutate calls at once. So we can change multiple columns all in the same mutate command, which is right here. So this code is the exact same as the previous code I executed, except in addition to changing the month column, we're also going to take the city column, and wherever there's a dot, we're going to replace it with an underscore. So for instance, if it were loss.angeles, it would be loss_Angeles. Sometimes it's nice to do this because there are certain programs where if your columns have dots in the name, they might have trouble with that and they prefer underscores. So we're going to change the city column, and we're also going to change we're going to make a new column called relative index, which is the current local index column divided by the national index column. And let's press play. And that didn't output anything to the screen, but let me just click. If I want to output it to the screen, what I can do is I can pipe this to a print function. Let's try that. Error. Okay, so that didn't work because, let me briefly explain something. So for all of these commands we ran up here, I took the housing clean data set and I manipulated it in certain ways, but I never saved that information. Here, for later functions that we'll run, I actually overwrote the housing clean data set using this assignment operator. So here we actually saved some of the manipulations that we did. So here again, we took housing clean and piped it through all of these operations and then saved it as a new data frame, new tibble, sorry, that's called the exact same. So it may have been a little better if I made it housing clean 2, just to kind of save my progress, so that we have 3 tibbles. But anyways, it was overwritten such that it didn't recognize this national US column because I had changed it. But if I type housing_clean down on the console, and I press enter, again, because it's a tibble, it's only going to show the top. Let me make this a little bigger. So there are, about 7,000 rows, and it only showed the first 10. And as we can see, we have renamed the national .us column, and we've made a new column called relative index, which kind of shows how this city is doing, taking its local index and dividing it by the national index to make a new column. So this 0.931 corresponds to this divided by this. So within this one mutate line, we did 3 different operations. So let's say we've manipulated our data table in a bunch of different ways and we want to save it in some format. We can use this write_CSV function and just give it the name in R of the tibble we want to save, and then the name that we want to save it as in the current directory that we're in. So if I run this code, as you can see, something over here popped up, housing_dataset_clean.csv. So now next time we start R, we could even just load this data set here, or we could share this with collaborators. Okay, So I'm going to spend just the next 5 minutes or so, or 10, going over these filtering functions in dplyr, which can also be very useful. So sometimes we need to filter data sets, and we do this by selecting particular rows that meet particular conditions. And it'll be clear how the syntax of this is once we get into some examples. And we set these up with logical tests, for instance, true or false. So logical variables in R, again, are either true or false. So here we're going to use this filter function to select rows that meet this particular condition. So we're going to take the housing clean data set and pipe it into filter, and we're going to take any rows in which the city column is equal to Boston. So here we have 2 equal signs. This is very important. If you only use 1 equal sign, you will get an error. So a single equal sign is usually used to assign values to a variable. For instance, the variable city, we'll set it equal to Boston. But if you want to test whether or not something equals 1 or equals Boston, you need 2 equal signs. Okay, let's press play. And as you can see, now under the city column, we only have data points that correspond to the city Boston. This filter function can also be fed multiple tests all at the same time. And if you separate your tests by comma, you can interpret this as, I want to filter my data set for Boston, and I want to filter it for the month of August. So this is an intersection. It finds all rows that have both Boston and August. And let's press play. And as you can see, that's exactly what happened. All of our rows correspond to Boston, and it's only for the month of August. So again, I said that this comma here is interpreted as and, or the intersection, but you can use other logical tests as well. So for instance, we can also use a pipe, which stands for or. So to just read what this code does in plain English, we'll take the housing data set, we're putting into the filter function to get only the city of Boston and any month that corresponds to August or January. So as you can see, now we have the city of Boston, and for the year 1987, we have January or August. So we can use this filter function along with other functions to get useful subsets of our data to kind of get a handle of, what's happening. For instance, which cities have the highest index, which have the lowest, etc. Let's say we want to see the 3 years when the relative index in Boston was the highest. And we'll just use, the month of January because, there are 12 months for every year. And let's say we'll just, for each of the 3 years, say 1987, 88, 89, we'll use January as the best estimate of what the relative index is for that year in Boston. Okay, so when was the relative index in Boston the highest? So first, we'll take our housing clean data set and pipe it into this function where we only look at Boston, again, because the question was only interested in Boston for the month of January. And we can use this arrange function where we want to arrange our tibble by the column named relative index. And we're going to arrange it in descending order. So that's what this DESC function does. If we did not include this, then the arrange function would go from lowest to highest. But now it's going from highest to lowest. And then we pipe this output into the select function, which is going to select both the year column and the relative index column. So just a reminder, the select function takes only certain columns that you specify from your Tibble. And then we can lastly pipe that into a function called head, which only displays the top portion of your Tibble, but we can feed it an argument n is equal to 3, which means it'll only display the top 3 lines of this Tibble. So what this is essentially doing is we're looking at Boston in the month of January. We're going to arrange it such that it goes from highest to lowest, select the year and relative index column, and look at the top 3. So this should correspond to the top 3 relative indices for Boston. And here's the answer. So you can see in year 2003, 2004, and 2002, Boston had its highest relative indices. And I'm just going to modify this code slightly just so you can see how, there are more ways to answer this question. Let's get rid of this descending thing. Let's say we forgot what that was, or that it existed, and we only remembered that the arrange function exists. So now what's happening? So now it's going to arrange it from lowest to highest, such that if we look at the top 3, these are going to be the lowest relative indices. So that's not going to answer our question, because we want the highest. So instead what we can do is, instead of looking at the top 3, we can use this tail function that looks at the bottom 3. So again, here's the answer, where here's the highest, the second highest, and the third highest, because we've used the arrange function such that it sorts it from low to high. But here, the highest one is on the bottom. So if we use descending instead, that's kind of nice, because then it is arranged such that the top relative index is also on top. The highest is also on top. Okay. Sorry, I'm going a little over, but just one last very useful way to use this filter function is getting rid of missing data. Most data sets have some type of missing data. And to do this, we'll use this is.na function, which will return a vector that's true if there is missing data and false if there's no missing data. So for instance, if a particular cell has a number, character, etc., then that will be interpreted as true. But if it has an NA, then those rows get filtered out. So for instance, we can take our housing clean data set and put it into this filter function, but we give this filter function this is.na local index. So this should filter out any rows that have missing data for the local index column. And as you can see, that didn't work. So why didn't it work? It looks like local index is all now exclusively NA. So the reason this happened is because is.na returns true if local index actually corresponds to NA. So this actually behaved exactly as we typed. If we want, so this filtered our data table for missing data, which is the exact opposite of what we want. To filter out missing data, you simply include this exclamation point, which turns all of these trues into falses. And if we press play here, you can see now anytime the local index corresponds to a number, it's kept. And if it corresponds to NA, it's removed. And if we just highlight this little piece of code in the filter function, now I'm going to press, I'm going to run this. Oh, sorry, it says local index not found, because that's not an object. It's only an object recognized within housing clean. But basically what this corresponds to is this is a vector that has a bunch of elements. It has as many elements as local index has. And anytime there is an NA, that value is false. And anytime that it's not NA, that value is true. And so filter uses this series of trues and falses in order to filter your data set. So that's kind of just what's happening with this logical test here. So that's all we have today. Please let me know if you have any questions, but we tried to document this code as much as possible in order for you to run some of this stuff yourself. But if there's anything mentioned in here that we did not thoroughly explain, do let us know. And this will be the first installment of 2 workshops on Tidyverse. So yeah, stay tuned for more ways to manipulate data using these Tidyverse functions.